Thank you. Thank you very much. Hello, everybody. Before I get started, I just want to say thank you so much to Angelina and to Wilkin for all the great work putting this together. And I want to say thank you to Tobias, to David, and to Vladimir for the fantastic presentations. Really great work. Make sure that you check them out if you didn't see them, because a lot of amazing demonstrations and cool stuff. Anyway, hello, I am Dead Program. I am here with GopherBot, which is my programmable robot plushie, entirely coded with TinyGo. And I am here at La Pipa in beautiful northern Spain, where I do my stream every week. Check it out at twitch.tv/lapipa.tv. So without further ado, this is Go Without Wires. I am Dead Program, technologist for hire, you know that, at the Hybrid Group, where we are all technologists for hire. Well, aren't we all technologists for hire, really? But yeah, but specifically. And clients, most interestingly, the company Northvolt, where we are helping this wonderful Swedish company create the future of energy. Check them out. So, but also a lot of open source projects that we've over the last years. GoBot, which was one of the first hardware control software written in the Go programming language. GoCV, which is a very popular wrapper around OpenCV in the Go language that's used in a bunch of cool projects, very active project. And of course, TinyGo, which you much about from some of our other speakers, a really amazing project that we're happy to participate in. But this is a talk about wireless networking. And of course, when we mean wireless, we mean this time it's personal. Yes, we're talking about wireless personal area networking. Of course, Bluetooth. I mean, what other wireless personal networks are there? Actually, there are a few, but Bluetooth is the most popular. And so earlier this year, we released Go Bluetooth, which is a package written in Go that is specifically to let you use this very powerful, most popular wireless standard ever created by sheer number of devices. On Linux, of course, you need Linux. I mean, Linux is very important. Mac OS for all the hipsters and people who are cool. Windows 10, we only have minimal support still, but there is some. It needs more work if you're a Windows person. And then, of course, bare metal, which is where we run on microcontrollers, such as the one built into GopherBot, using the Nordic Semiconductor soft device, which is not open source, but is a free license. So very cool software. So, but what's so good about Bluetooth anyway? I mean, why use Bluetooth as opposed to Zigbee or one of these other, wireless personal area networking standards? Well, first of all, low power use. We don't want to use our precious batteries to stay connected. Another is high speed. You can do video, you can do audio, you can do lots of other things over Bluetooth. And then most importantly, it is already everywhere. I mean, don't you want to program for hardware that everyone already has? It's kind of a classic example of increasing returns. So, but which Bluetooth is for you? You've heard all these different Bluetooth this and Bluetooth that. Bluetooth low energy, perhaps. Or maybe you want to use Bluetooth smart. Well, haha, fooled you. There's actually only one Bluetooth. They all have these different names along the way, but Bluetooth is Bluetooth, no matter what kind it is today. So it's very good to know, very important. So how Bluetooth works. So Bluetooth, I'm going to put GopherBot down here. So Bluetooth, we're going to go over this entire diagram here that shows all of the Bluetooth low energy stack. No, just kidding. We're not going to go over all these details. Instead, if you want to know more about the very low level details of the Bluetooth low energy stack, check out SparkFun has a great introduction along with some others. But let's just talk about the roles of Bluetooth that you would use as a developer when you want to write some code that uses this Bluetooth interface. Well, first of all, we have peripherals. Peripherals like your mindfulness headset or your heart monitor. And then we have centrals like your cell phone or your car. And so this is a cool diagram created by Adafruit, and it shows in the middle our centrals like our mobile phone, tablet, computer, and then around it, surrounded by this embarrassment of riches of peripheral devices out in the world, all supporting Bluetooth. So in order to get started, we have to use the generic access protocol. So what does that mean? Well, when peripherals want to be found, of course, they advertise. So we're going to start with a demonstration that uses the Adafruit Itsy Bitsy NRF 52840, which is a Nordic Semiconductor NRF 52840 chip with a 32-bit processor. It's a 64 megahertz ARM Cortex M4, and it has about 1024K of flash memory. So let's take a quick look at our, here is the Itsy Bitsy. It's very small. You can see it. I mean, it really is small. It's a very, very cool board, and I use it for a lot of interesting things. So let's take a look at some code that we're going to use to program the Itsy Bitsy. So the code for the hello world of Bluetooth is advertising. So we can see package main, just like we would in any normal Go program. We're going to import the time package, and we're going to import the tinygo.org/x/Bluetooth package. And that's the package we're going to use to actually communicate with the device. So the first thing is that we have our Bluetooth default adapter. Since most devices only have one Bluetooth adapter built in, we have this shorthand for you. And so we're going to put that into our adapter. And so our main program, first we're going to enable the adapter. We're going to call this must function so we don't have to check for the error repeatedly in this code to make it a little bit shorter. So first we enable the adapter, turn it on so we can use Bluetooth. Then we're going to create our default advertisement, which is whatever we're going to say out to the world. And then we're going to configure our advertisement so that its handler function is going to be able to provide this information that the local name is Go Bluetooth. Then we start advertising, and that's it. We're done. From that point on, all we have to do is just sleep for an hour and let the advertising take place. So let's go over to actually flash the code. So if I say make advertising, and I'm going to go ahead and plug in my Itsy Bitsy, and I'm going to plug it in here to my computer. And then from there, we can go ahead and flash it by running this make command that I've created. So it's going to, the program is 9K in size, which includes the entire Bluetooth access code and everything else. And so now if we take a look at our micro, then we can see that, in fact, nothing is happening. Right. Of course, because we need to actually listen to this. So let's go and unplug our device here, the Itsy Bitsy, and let's plug it into a battery. And that way, with this battery, it will start advertising again. And now let's put it aside for the moment, and we'll go on to the rest of our talking, which is, what about when centrals are looking for peripherals? We have a peripheral that wants to be found, but we do not yet actually have anything that is looking for it. So when centrals want to find peripherals, they scan. And so when they scan, we're going to take a look at the code here real quick of our scanning code. So let's see, get out of Zen mode. Whoops. There we go. And we'll go to our scanner. So the scanner here is actually very, very similar to the code that we wrote before for advertising. We have our main package. We import the Bluetooth package. Then we have our adapter, a default adapter, in this case on my computer. And then we have to enable that adapter in our main function, turn it on, and then we start scanning. So when we turn on our scanning, we have our scan handler here. Wait, something's missing. There we go. So once we start scanning by calling the adapter.scan, we pass it our scan handler, which is the function that's going to be called whenever a device that we find is located. And that scan handler here gets past the adapter, and then it also gets past the scan result for each time. I think we can turn off the speaker. Vamos a quitar los altavoces. So then the device has got a string which corresponds to its address, and then also the relative signal strength of it, since you've probably seen this before, devices that are closer or further, and then the name of the device. So let's go ahead and run this by saying make scan. And you can see here, Go Bluetooth is showing up. That is our actual device that we flashed before. So if I unplug it, it'll stop showing up. And if I plug it back in, it should, if I can plug it back in correctly, there we go. You'll see that it will appear again. You see how fast a microcontroller boots. It's very, very fast. All right, so now that's our scanning. So, and then what happens? Well, once our central has found our peripheral, they connect. Oh, isn't that cute? By the way, there is no actual contact between centrals and peripherals. That was a metaphor. All right. So, but let's keep the metaphor going a little bit longer since we're in the mood. Connections are exclusive once they're made. I mean, for the lifetime of the connection. So if you disconnect, then your new connection will be exclusive. And of course, once you're connected, that's when we ask the big question. What data do you have? So for that, we're going to need the generic attribute protocol, or GATT, which is the other main category of protocols when using Bluetooth. So we have services, and each of those services has a unique identifier so that it's unique in all the world for that one service. And then it has a list of the characteristics. For each of those characteristics, it also has a universal unique identifier, and then the actual data. So if we look at this cool diagram that was created by Adafruit, we can see here that we've got a service and a bunch of characteristics under it, and then a different service and a couple of characteristics under that. And so this defines pretty much the whole high-level standard of what we care about when we're using Bluetooth, low energy. The process of figuring out what that data is actually called discovery. And we don't have time right this instant, but what I thought I would show you, since we don't have time to look at the code, I brought another toy with me so we could go back to some scanning. This is an Adafruit clue board, which has another NRF 52840 semiconductor, Nordic Semiconductor microcontroller. And then we're going to plug into it with just a battery. I flashed this code earlier. And I could plug it in here real quick. Then you will see that as it boots up, we can actually, that's a little out of focus, but you can see it's scanning, and you can see Go Bluetooth appearing on the display of this device. So a microcontroller can be a peripheral, or it could be a central, right? So we'll just leave that running. And so there are well-known services and characteristics that are out there defined by, of course, the Bluetooth Special Interest Group, of which Nordic Semiconductor and a number of other countries are, or companies, I should say, they're all members. So these well-known include, for example, the battery service. If you've ever been in your car and you wondered how does your car know that your phone is on low battery, it's because of the battery service. There's the location and navigation service, which would be the opposite, how your phone knows that the car's GPS is working. And then the heart rate service, which is if you were going to connect a heart rate sensor, this is how you would be able to do it. So let's actually take a quick look at a heart rate sensor. We're going to use the Adafruit Circuit Playground Bluefruit, which is another board from Adafruit, awesome company. And it just so happens that's the board that's built into GopherBot. So what I'm trying to say here is we're going to use GopherBot now. GopherBot, do you have a heart? Well, GopherBot does not have a heart. However, GopherBot can have a heartbeat. So let's take a real quick look at that code. So the heartbeat, what we're going to do here is the same pattern as what we saw before, right? Let's see, Control KZ for Zen. So we have our package main. We have the standard packages from Go, Rand, and Time. We're using the Bluetooth package. Once again, the default adapter. And this time we have a characteristic, which is the heart rate measurement. So we enable our adapter, same as the other demonstration. We create a default advertisement, same as the other demonstration, the advertiser. But this time, our advertisement options include the local name and which one of the service UUIDs that we're going to actually advertise that we support. In this case, we're going to say we support the standard service UUID for heart rate, which is a previously well-defined, well-known UUID that's any heart rate monitor will support. So we start advertising, and then we're going to add our services. The Bluetooth service has the Bluetooth characteristic for the heart rate measurement. So this is the actual data itself, and we're going to start with a heart rate of 0. And we're going to set this permission, which says we can receive notifications from the device. This is how Bluetooth Low Energy is so efficient. Instead of continuously asking a device, do you have new data? Instead, it receives a notification from the peripheral device saying, here's your new information. And then we're going to start the heartbeat. So the heartbeat, it's going to check the time, and then we're going to show the pulse somehow by flashing some lights. We're going to sleep for however long our heartbeat is supposed to wait for, and then we're going to vary it between 65 and 85 beats per minute, which I've heard for a GopherBot is relatively normal. And then last, we're going to write this to the characteristic, which is going to send the information from the peripheral to whatever centrals are listening. Okay, so let's go and let's take a look and let's actually run this code. So we're going to say make heart rate circuit play. And so I'm going to plug in GopherBot. Don't worry, GopherBot, I'll put you back normal afterwards, but right now we need to program you so you've got a heartbeat. So let's plug in, and then we'll flash the board. This is only a 13K program, a lot smaller. And now we can see actually that GopherBot's heart is rotating at approximately every second, depending on how fast or how slow. So let's unplug from the computer and let's plug in the battery. That way you believe me that, in fact, I'm not faking this, it's all real. So we're going to plug in GopherBot, and oh yeah, let's take a look and see if we spot in our scanner. Yeah, we could see that we've got Go Bluetooth still, and then we've also got Go HRS, which is our heart monitoring service. So just to prove to you, though, that in fact, this is completely standard, what we're going to see is we're going to demonstrate this using, if I go back to it here, using the heart rate monitor that we're going to show is using Android. So I'm going to plug in my telephone here, and let's go over to the Linux. I'm going to plug in my phone, and then what I'm going to do is I'm going to run a program that's called screen copy. Whoops. Oh, yes, I have to permit. And then let's try running it again. Okay, so now you can see my Android phone has appeared now on the screen. So if I go to this application from Nordic Semiconductor called the NRF Toolbox, it supports a bunch of very well-known services, and one of them is the heart rate monitor. So if I connect here, we see Go HRS is listed under the devices. So if I connect to it, and we can see, here's my heart rate coming through. Actually, it's not my heart rate. It's actually GopherBot's heart rate that's coming through at the same time. So GopherBot has a heart. That is so awesome, right? Who knew that robotic plushies could have a heartbeat? Okay, let's keep going because we have little to do and lots of time. No, wait, strike that, reverse it. So there are also custom services and characteristics, not just the well-defined ones, but that usually big companies get together in their consortium, but there's lots of other devices in the world. And for all these other devices, for example, like drones. So I, of course, love flying drones, and I've never found a drone I didn't want to fly programmatically. So we're going to build a TinyGo flight controller. So the first thing is that we're going to use a Parrot Mambo mini drone, which if you've maybe seen a couple of my talks, you see that I love these little Parrot drones. They're very inexpensive. They're very cool. Kind of hard to see in that angle, but so this is also got a 3D printed enclosure with a first-person video camera. So let's go ahead and turn this on. And you can see that the eyes are going to start flashing red because it's waiting for something to connect to it. Okay, so what are we going to connect to it? Well, for that, we're going to use, once again, the same chip that we used initially, the itsy bitsy NRF 52840. So this is a very, very cool little board. And I used it in order to make this, which is a small flight controller with only one joystick. So it's hard to fly a drone with two joysticks, but I'm going to do it with only one because that's the most minimal possible flight controller I could think of. So let's take a quick look at the code. So there's actually two pieces of code here. The first one is that we're going to go take a look at the drone client code. Now, keep in mind here that the drone is a separate Bluetooth device with its own firmware, and we're not reprogramming that firmware. This is actually the client that we're going to use. So it's a client wrapper from the flight controller as a proxy for the drone itself. And we can see here it's got a main, wrong code here, wrong code. Let's go back to the mini drone. It's in the other one. My bad. There we go. Okay. So this is the mini drone code, and it's got a few different services and characteristics that it defines based on the not well known, but having these UUIDs, which are defined by Parrot. And so it's going to be a wrapper around the Bluetooth functionality. So when we say new mini drone in our code, we're going to pass it the actual Bluetooth device that we found. And then based on that, when it starts, it's going to discover the services. Which ones? The services we use to fly the drone, of course. And then once it's found those, it's going to discover the characteristics for each of those services. First, for the command characteristic, which is what we use to send commands to the drone, like take off and land. And then the flight status characteristic, which is how we determine, is it flying, has it crashed, etc. And so if we go take a look at the other code that I was trying to show you a minute ago, which was the actual flight controller, the flight controller is what's running on the itsy bitsy board itself. And for that, it looks a lot like the code that we've seen previously. A few differences, because this particular board, we have, as I showed you before, we have a display. It's an I2C SSD 1306 display. So it's just a very, very small little LED OLED display, an analog joystick, and of course the buttons, right? So if we go back to our code here, we can see we are initializing the I2C interface just so we can look at the display. And then the important part is that we're doing the same thing as what we did in our other Bluetooth code, right? We're enabling our default adapter. We're scanning. In this case, we're going to scan for the drone's MAC address, since every Bluetooth device has its own MAC address, so we can find it by that. We're going to...
Ron, welcome back.
I don't know what happened there. From our side, everything looked fine. That's a bummer. Sorry, where was I? So right now we should be connected. If I flash the code here, it should flash the board with the right code. Am I still coming through okay? Hopefully.
Yep. All good.
So I've just flashed the flight controller with this latest code. And so if we go over to the micro camera, we can see that it's actually displaying the joystick. And so theoretically, I am connected to the drone. So now, if we go over to the drone's camera, you can see that actually this is the drone's eye view, and here's my flight crew. So let's try the takeoff and see if it works. So I'm going to press the takeoff button. It's not the best connection, maybe. It's a little interference, but I think we'll be all right. So I'm going to press the takeoff button and let's see what happens. Okay, and we're flying. So we're actually sending the Bluetooth commands from the drone. And if I press this other button, I can hopefully get some height. So you can see that, in fact, I am here. We'll flip around. The video is a little odd quality, but yeah, there I am. Hello, people of the internet. All right, so this is the drone that we're flying entirely through Bluetooth, and it's actually almost out of battery. That's why its eyes are flashing at me. So I guess we better land. Oh, just in time. We've lost video. We've lost contact with the probe. What does that mean? Well, it means that our demonstration is over of the drone. All right. Well, I hope that worked. So, in conclusion, no contact with other physical objects or living beings? Well, no problem, of course. All you need to do is go without wires. So please check out tinygo.org/Bluetooth. That's where you'll find the information about Go Bluetooth. Runs on Mac, runs on Linux, some very initial rudimentary Windows support, and runs bare metal on microcontrollers. And with that, I will say thank you so very much. And are there any questions?